We've always had engineering and IT center for Daimler in India for more than 20 years now, which was called as MBRDI. So MBRDI was catering to all parts of Daimler, right? Like passenger cars and commercial vehicles, trucks and buses and financial services. And when globally the split was announced, it was also decided to create a separate entity spun out from MBRDI to cater to the Daimler truck, which is a commercial vehicle business, to cater to the Daimler truck for engineering and IT. And that is how the concept of DTICI was born. And then we went live on 1st of December 2021, which is also the date when the global separation happened. And that was also the month when Daimler Truck got listed in the German stock exchange.
Innovation is at the core of Daimler's mission. And can you provide some examples of innovative technologies or solutions that the Innovation Center has developed or is currently working on?
Yeah, I think I didn't answer your question fully last time. So, what are we focused on? So, we are focused on engineering and IT. And within engineering, we can broadly talk about two categories. One is the product engineering, which is the conventional mechanical engineering, electrical engineering, and so on. And the other is the software and electronics, which is basically the software and electronics that goes into the truck. Our trucks globally are drive-by-wire systems, which means there is a software and electronics between the driver and the truck. So it's basically a drive-by-wire system. That's what we're focused on. Back to your question on innovation. Yes, the center is focused on innovation. And today, if you see globally, our strategy is really focused on two things. One is the intelligence to drive, which is the software. Other is the power to drive, which is going from diesel to zero emission technologies. Right? So all the innovation that is happening in these two areas because that's where the entire auto industry is headed. It's just not Daimler Truck, but everybody has to move to zero emission because we have regulations. And there is a lot of carbon emissions that the commercial vehicles contribute to, which is not good. So we're fully focused on getting to zero emission, which is what we call as power to drive. And then the intelligence comes from the software. And that is what we call as intelligence to drive. And these two are also the focus areas around which we innovate within DTICI.
How does DTICI collaborate with other Daimler entities globally? And what benefit does this bring to the development of new technologies?
Well, the way we collaborate is we are an integral part of Daimler Truck organization globally, and we are considered as the largest engineering center outside of our home locations within Germany and US. How we contribute is we contribute across the value chain of engineering, whether it is chassis, whether it is cabin, whether it is e-motors, battery electric, software and electronics, and IT. So that is how we collaborate with the global business. And across the value chain of engineering, we have engineers from here who are integral part of the global teams.
And what is the role that the Indian market is playing in the global strategy for commercial vehicles, and how does DTICI how is DTICI contributing to this strategy?
The Indian arm of Daimler Truck, which produces and sells trucks, is the DICV, Daimler India Commercial Vehicles. It is based out of Chennai. So they have the Bharat Benz suite of products, which are sold in India. We do contribute to that product strategy, but we're not limited to that. Most of the
Okay.
engineering work that we do goes into our products in North America and Central Europe.
Okay, and when it comes to technology, we know that every day there's a new change. Only last month, around 200 AI apps, which are similar to ChatGPT, came into being. So, how does the Innovation Center stay up to date with the latest development in the field, such as AI, electrification, and connectivity?
AI we use mostly in analytics, in extracting intelligence out of data. For example, we have projects where we have, let's say, for example, predictive analytics, right? So what we do is we use AI and machine learning to predict when a part is going to fail, even before it fails, so
Okay.
that we can minimize the downtime of other trucks, because trucks are not fancy products. They're used to move things from point A to point B. And the fleets that buy trucks from us, they want highest amount of runtime and lowest amount of downtime. So every hour truck is off of the highway, then the fleets are losing money. So one way we use AI is to predict the part failure, right? For example, if a DEF pump is going to fail 4 weeks from now, then we predict those, and we preempt the part replacement. And this also has a huge impact on the warranty cost. So that is one area where we use AI and machine learning. The other area we use is how do we price our parts. Part pricing in the after sales is a very, very tricky business, because it depends on the demand. It also depends on how do we get our dealers to buy parts from us and not from third party. And pricing is a very sensitive topic there. So we use advanced analytics to give recommendation on what should be the part pricing. That drives the profitability. So like that, we use AI and machine learning in many, many domains of Daimler Truck, from engineering to after sales to logistics to manufacturing and so on.
What about the electrification part?
Well, electrification is an ongoing strategy. We have a suite of products which run on battery electric, but electrification is also contingent to how quickly the infrastructure is developed for charging and for availability of the batteries, the charging infrastructure, and so on. So we work across the value chain to make sure that we have everything we need to put the electric trucks on the road. We already have the first generation of electric trucks with our fleets. But the biggest challenge, and something that's very different from, let's say, a passenger car, is the range, right? A passenger car with a range of 300 to 400 kilometers is more than enough. But that's not going to cut it for commercial vehicles, because they run, if our trucks have to cross the Alps, right, in ferrying the goods within Europe, then they need 800 to 1,000 kilometers range. So that's the biggest challenge we're working on, how to get to that level. And also, it needs a very robust charging infrastructure. And there are other issues like how is the electricity produced? We are addressing the tailpipe emissions by building electric trucks. But if we are still producing energy using coal, then we still lose the game overall. So electrification is not just a product challenge. So there are three parts in electrification. One is the products, they need to be there. Second is the infrastructure, like how do you produce and store energy in batteries? And third is how do you make them cost competitive? Electric vehicles today are very, very expensive. So the governments are subsidizing that across the globe, but that's not a long-term strategy. So the price parity, the product readiness, and then the infrastructure readiness has to come together for us to achieve all the goals that are being set by different governments. So
Okay.
one is we produce the product ourselves, but we also work with the ecosystem to get the infrastructure going. So it's a systemic challenge. It's not one company or one sector for that matter can solve this problem end to end.
Coming to sustainability, which is like which used to be a buzzword, but now it is like the most important aspect. So, how are you prioritizing sustainability and environmental responsibility in in your innovation efforts? And what are the steps that the Innovation Center is taking to reduce the environmental impact on the products and the processes that you create?
The main area of contribution from a sustainability standpoint for an engineering center like ours is to make our products more and more sustainable, right?
Mhm.
And make our manufacturing processes more and more sustainable. So we use steel aluminum a lot, and that production is not a very green kind of a process. So we continuously optimize the materials that we use. But I think the biggest contribution from us is going to come in the way of creating the products, whether it is battery electric, whether it is hydrogen based, and how do we make sure that the energy that is stored in the batteries is used in the most optimal form, right? So energy is not just used for traction; it is used for heating and or cooling. It is used for a lot of other requirements within the truck or the bus. So we continuously optimize the energy usage using really advanced algorithms in the battery management system. So the contribution from DTICI is going to be around how do we create these products which drive sustainable environment.
Looking ahead, what are some of the biggest challenges and the opportunities that the Innovation Center anticipates in the coming year, and how is it preparing to address them?
I think the biggest challenge and opportunity is the talent. The biggest opportunity for talent is in India. There's no question about that. Why do we have engineering centers here? Because we have engineers who are extremely smart, very motivated, extremely inspired to solve these really big problems. The biggest challenge is talent, and biggest opportunity is also talent. But in the next 10 years, the automotive industry is looking to solve problems which haven't been solved in the past. Like if you look at the diesel engines, I mean, it perfected the art of diesel engines over the last, I don't know, 100 years, right?
Mhm.
But once we knew how to build diesel engines, it was incremental improvements. You go from Euro 4 to 5 to 6 to now 7. These are not breakthrough innovations. These are incremental improvements where you make the engine better, you reduce the NOx, you reduce the carbon emissions. But the problems we're trying to solve now, which is around battery electric, hydrogen powered vehicles, vehicles that are driven by software, and the innovation within the vehicle is centered around software and not hardware. Um, these are problems that we haven't solved in the past. So these are first time problems that everybody's trying to solve. And this is how we build a competitive advantage within the marketplace with our competitors. So I think that is the biggest challenge where we are solving the problems for the first time. Because if you look at battery electric vehicles, no university today teaches the course on how to create a platform for battery electric vehicles. Yes, we have had motors for hundreds of years, known how to store the energy in batteries, how to do the traction. But if you want to create a platform, no university teaches that today. So these are skills that people learn on the job and then they create, make mistakes, better them. So I think that's the biggest challenge our industry is facing, where a lot of the problems we're solving haven't been solved in the past. It's not incremental improvements, but new set of problems we're solving.
You spoke about the skill, or rather talent. So there is a need for skill improvement, and how do you address them in terms of? You also said about learning on the job, but do you have any input, any insights on how can you improve that situation?
Well, I think one is there are experts who have built these capabilities globally. So we have programs where our young engineers get to travel to those locations, work with those very experienced people, and learn from them. And for keeping our software engineers continuously updated, we have several programs, both through online trainings, through learning from the experienced people, and also learning on the job. We have many programs to continuously reskill them because in software there are tools and technologies and programming languages and algorithms that are getting developed every day, so they have to keep in touch with that. So I think we have a very structured way of how we train our engineers.
One more opinion from your end. What's your opinion on the hydrogen powered vehicles?
It's a it's an evolving story. So if you look at hydrogen, there are two ways hydrogen can be used. Hydrogen can replace diesel as a fuel,
Mhm.
which is burnt in the same internal combustion engine. It's just that we replace diesel with hydrogen. That's one way to do that. The other is the fuel cell, where you use the hydrogen to generate energy, which either runs the vehicle directly or charges the batteries. I think hydrogen this is my personal opinion. hydrogen definitely has a place in zero emission future. Battery electric by itself is not going to cut it, at least for the commercial vehicles. For passenger cars, I think battery electric will cut it because you don't need 1,000 kilometer range. I mean, nobody tries 1,000 kilometers between charging. But in the commercial vehicle industry, there is definitely a place for hydrogen. H2Is, as we call it, hydrogen internal combustion engines, they are in the process of getting certified as zero emission vehicles. Technically speaking, they're not zero, they're very, very close to zero. So if that happens, then there is going to be a parallel development of H2Is and fuel cell. This will be used in heavy duty long haul applications, right? 40 tonners going on a 800 kilometer, trip across the Alps or coast to coast in US. There is that place. The challenge here is the infrastructure. How do you produce green hydrogen? How do you store it? How do you transform it? And how do you create that infrastructure where you can refill a hydrogen tank? But I think for commercial vehicles, it's inevitable. We have to create that infrastructure, and hydrogen definitely has a place in the future ZEV commercial vehicle space.
Okay, but there is always a concern of this over the safety of hydrogen, particularly in regard to the potential leak into the atmosphere and the combustibility of hydrogen.
Well, I think those are challenges that exist, and even battery electric has the challenge of fire hazard while charging, because if you charge it too fast, then there are hazards. But I think those are challenges which the engineers will solve over the next decade or so.
Thank you, Mr. Vaidya. Thank you for your time and thank you for sharing the insights.
Thank you very much.